This video will contain several special cases, so-called, the first of which is multiplying binomials by the FOIL method. I don't really like that term because we could actually apply what we did for, in general, multiplying two polynomials. But here's the method. Multiplying binomials by the FOIL method. Step 1, multiply the first two terms, the two first terms of the binomials to get the first term of the answer. Then find the outer product and the inner product and add them if you can to get the middle term of the answer. And then step 3, multiply the two last terms of the binomials to get the last term of the answer. So again, as I said, I'm going to write these as I would just multiplying two polynomials. My first example is y minus 5 quantity multiplied by the quantity 4y minus 3. So I'm going to write this as y multiplied by 4y minus 3 plus, well, actually minus 5 multiplied by 4y minus 3. Now distributing the first term, I have 4y squared minus 3y. And distributing the second set here, I have minus 20y plus 15. I can combine those two terms in the middle, the minus 3y and the minus 20y, so that my answer is 4y squared minus 23y plus 15. Now, the part of this that would be the first two would be y times 4y, which is the 4y squared here. The part that would be the outer terms would be y times minus 3, which would be the minus 3y. The inner terms would be negative 5 times 4y, or the negative 20y. And the last would be negative 5 times negative 3, or the positive 15 that I had in my second step. All right, the second example I have is the quantity 5a plus 2 multiplied by the quantity 7a minus 4. And I would again write this as 5a multiplied by 7a minus 4 plus 2 multiplied by the quantity 7a minus 4. Distributing the first set of parentheses, the 5a, I would get 35a squared minus 20a. And distributing the 2 to the second set of parentheses, I would have plus 14a minus 8. I can combine my two middle terms, negative 20a plus 14a, so that my result is 35a squared minus 6a minus 8. The next example, I have the quantity n minus 8 multiplied by the quantity 3n plus 5. Again, I would write this as n multiplied by 3n plus 5 minus 8 multiplied by 3n plus 5 altogether. Distributing the n on the first term would result in 3n squared plus 5n. Distributing the negative 8 on the second would result in negative 24n minus 40. And I can combine my 5n term and my minus 24n. That would be negative 19. So that my result, final answer, is 3n squared minus 19n minus 40. Now the last example with the FOIL method in it is the quantity 6x plus 5y multiplied by the quantity 5x minus 2y. I would again write this as 6x multiplied by 5x minus 2y plus 5y multiplied by the quantity 5x minus 2y. Distributing 6x to 5x minus 2y would result in 30x squared minus 12xy. Notice the two variables there. Distributing 5y to 5x minus 2y would result in a plus 25xy minus a 10y squared. Now I can combine the xy terms, which is the negative 12xy plus 25xy. So my result, bringing down the 30x squared and the minus 10y squared, would be 30x squared plus 13xy minus 10y squared. Now for our next special case, we have what we call square binomials. To square a binomial, we simply write the binomial twice and use the FOIL method, or as I prefer, multiply them like general polynomials. Multiply every term of the first polynomial by every term in the second polynomial. So we can write a plus b quantity squared as a plus b times a plus b. Let's apply this. A few examples. We have x plus 7 quantity squared. I'm going to write this as x plus 7 multiplied by x plus 7. In the general polynomials method, I would write this as x multiplied by x plus 7 multiplied by x plus 7. Distributing an x to x plus 7, I would get x squared plus 7x. Distributing a 7 to x plus 7, I would have plus 7x plus 49. And I can combine the 2x, or the 7x terms, so that my answer is x squared plus 14x plus 49. They're actually the general formula for square binomials. You might look into that if you're interested. Next example I have is 5a plus 1 quantity squared, which I will write as 5a plus 1 parentheses multiplied by 5a plus 1 in parentheses. Which the general polynomials method, I would say 5a multiplied by 5a plus 1 multiplied by 5a plus 1. Distributing the 5a to 5a plus 1 would result in 25a squared plus 5a. And distributing 1 to 5a plus 1, that would result in 5a, or plus 5a plus 1. And I can combine 5a and 5a to be 10a. And bringing down 25a squared, that's 25a squared plus 10a, and bringing down my plus 1. 25a squared plus 10a plus 1. Our next example of a perfect square is 3x minus 7 quantity squared. Which again, I will write as 3x minus 7 in parentheses multiplied by 3x minus 7 in parentheses. General polynomial multiplication, I'll write this as 3x multiplied by 3x minus 7 multiplied by 3x minus 7. Distributing a 3x to 3x minus 7 results in 9x squared minus 21x. And distributing a negative 7 to 3x minus 7 results in minus 21x plus 49. I can combine the two x terms to result in 9x squared minus 42x plus 49. Notice the middle two terms have been identical in each of these. 7x, 5a, and 5a, negative 21x, negative 21x. Not a coincidence. Now for our last example, we have the quantity 2x minus 5y squared, which again I can write as 2x minus 5y multiplied by 2x minus 5y. And I can write that as 2x multiplied by 2x minus 5y minus 5y multiplied by 2x minus 5y. Distributing the 2x to the first term, to 2x minus 5y, results in 4x squared minus 10xy. And distributing negative 5y to 2x minus 5y results in minus 10xy plus 25y squared. Negative 10xy and negative 10xy combine to be negative 20xy. So that my result is 4x squared minus 20xy plus 25y squared. And that is the end of that special case. Now we have one more special case, and that is what is called a difference of squares. And we kind of state this as find the product of the sum and difference of two terms. So in this case, the product of a sum and difference of two terms, we have the quantity a plus b multiplied by the quantity a minus b, and that is going to be equal to a squared minus b squared. Notice that the expressions a plus b and a minus b the sum and difference of the same two terms, those are called conjugates. A plus b, a minus b, those are conjugates. All right, well, we have 3x plus 5 quantity multiplied by 3x minus 5 as a quantity. Well, based on that statement, a plus b multiplied by a minus b, those conjugates, it's going to be a squared plus b squared. Now, you could distribute those two, a plus b, a minus b, multiply those together, and you should notice you end up with the a squared minus b squared. All right, well, 3x squared, I'm going to write this in this way, 3x squared minus 5 squared is what this is going to result in based on that formula. So that would be 9x squared minus 25. Now again, you might multiply that out and see that it is equal. Next example I have is 2x minus 7y multiplied by the quantity 2x plus 7y. So I have 2x minus 7y, 2x plus 7y. There's the emphasis. Those two are conjugates. Those are conjugates, which means we can apply this formula. So I will have 2x quantity squared minus 7y quantity squared, which will be 4x squared minus 49y squared.